You should have done the circuits rote learning, so you've learned all the definitions, all of the key bits that we need to know. This is trying to get you to understand how a circuit works. Just the basics. First of all, let's look at a circuit. Now, we need to think about what carries the energy, which is given energy at the battery, uses it around the circuit. So obviously it's electrons that are in the wire already. We talk about them coulombs of electrons, because that's a big number. Like in chemistry, we talk about a mole of atoms. So we talk about a coulomb of electrons. What gives them energy? Well, that's the battery or the cell. And it transfers energy to other forms. Here it's the bulb, it could be a motor, a buzzer, it could be anything. And the ammeter, if I put an ammeter in series, it would measure the current or the number of coulombs per second. That's how a circuit works. The electrons are already in the circuit, they're already the delocalized electrons that are in the metal, they're not produced by the battery or anything like that, they're not used up. Okay? Let's have a little look. There's a couple of rules you need to know. First rule, the energy I gain, remember this is 12 joules for 1 coulomb, 12 volts. If I gain 12, I've got to lose those 12 as I go around the circuit. Well, I've started with 12, so I've got 12. I've lost 8, so I've got 4 left. I lose some there, and I lose 3 more. Well, 12 equals 8 plus something plus 3. What is that? Well, easy, that's 1. So the voltages where I gain is equal to the voltages added up where I lose. Okay? Let's look at this. If I put that in a rule, I would say the sum of the potential differences across the components, 8 plus 1 plus 3 in this case, equals the sum of the potential difference across the batteries, because of course I could have more than one. Okay, usually we just have one, so it's easy. Learn it. Next one. Let's look at that one. Well, I've got 6, 1, 5. What do they add up to? Well, they add up to 12 again. Okay, nice and easy. Next rule. Sorry, ignore those two. I've got another one. I've got a 6-volt battery, look, two cells, and I'm going to use those 6 volts around the circuit. So that plus that must be equal to 6, but they're the same resistor, look. So it's going to split equally. So I'm going to have 3 and 3. 6 equals 3 plus 3. Right. What about this one? Alright, now, ignore those resistances because now they're different. That's wrong, we should change that. We've got 12 and we've got 3. Well, what does that add up to? Don't worry about it, they're together, 15, easy peasy, that's all we have to do. What about this one? I've now got an ammeter measuring current, number of coulombs per second, and it's 0.5 here. Now, because it's a series circuit, only one loop for the electrons to take, think of it like a bicycle chain. As I pull one bit, we all move at the same speed. So it means that the current everywhere is the same. And most people get confused with this. They think it's used up by this or some nonsense or a slowed down by this. But of course the resistances decrease the speed of the whole thing. Just like when you pedal, you only pedal in one place, but the whole chain moves at the same speed. Okay? So how do I put that as a rule? Well, my rule number 2 for series circuit is the current is the same everywhere within that closed loop. Nice and easy. Just learn that one. So what about? It's 0.7 now. What's this one? What's this one? Well, you should know that's easy. It's the same everywhere in that closed loop. Next one. I've got a voltage here, and I've got 3 different voltages. Now, if you know from the first rule that this is equal to that, plus that, plus that. But I don't know what these are, so I need a bit more information. What about if I told you it was 5 amps? How could you work out one of these? Well, we could work out this one, couldn't we? Because we've got voltage, we're trying to find out, we've got a resistance, and we know the current is there. So what relates to them? V, I, and R. Vir, Ohm's law. So we need to know our equation. Write it out, we can plug our numbers in, and we get 10 volts. What about for this one? Well, I've now got 3 and 5, so I've got 15. This one I've got, again, 5 and 4, so I've got 20. And we know that that plus that plus that is equal to that one. So the most complicated thing we could be asked to do is easy, isn't it, if we break it down into small chunks. Last one. If I've gained 3 volts here, now this is different because now we've got how many? We've got 1 closed loop, we've got 2 closed loop, we've got 3. Because there's more than one path, we call this a parallel circuit. And we need to think about each loop by themselves. So I'm going to gain 3. I could go along here. I could go along here and then back. So I must lose those 3 again to use my first rule again, that the amount I gain is the amount I lose in a closed loop. So what will that one be equal to? Well, that one must be 3 volts. But look, I can gain 3, and I can go down here, can't I? I can go across there, and I must lose those 3 volts there again, because I've got nothing else before I go back. So that one must be 3 volts. What about the last one? You guessed it, it's 3 volts. Okay. So parallel is just the same as a series, just a bit more complicated, because I've got more than one loop. So how would I write this as a rule? Well, I would say the potential difference across each branch, 1, 2, 3, is the same. But, can you see that the current is different in each branch? And what can I do? Well, if I started off here, let's imagine all of us, let's imagine 10 of us started here. We all got to go along here, so all of this is 10 amps in here, the current. Some of it's going to go this way, some of it's going to go this way, some of it's going to go this way, and we're all going to meet up at the end. So, if I've got 10 amps, 6 go this way, 3 go that way, 1 go that way, they all add up to 10 at the end. Okay, so perhaps if I told you that and I asked you to find that one, you can quickly find that it's 1 amp. Last one, let's see if we can apply this. Well, what would my supply be? Think about it, pause it if you need to. That's 1 volt, so this one, if I've lost 1, there's nothing else to lose it in that loop. I must have gained 1, mustn't I? Or what must that be? If that's 1, that must be 1, that must be 1. Easy as the first one. Okay? The voltage across each branch is the same. And that's it. Go and apply it, go and try the quizzes, go back to this video if you need to. Good luck.